In the first lesson, we looked at a linear quadratic system of equations where we had a parabola and a line. In this particular lesson, we're going to look at a quadratic quadratic system. So basically, what we're going to look at is we're going to look at having two parabolas that are going to intersect each other, and we're going to determine where those parabolas actually intersect, what their points of intersection are. Now, I'm going to start with part B of this particular example. We're actually going to graph our two equations that we have up here, and we're going to determine our solutions graphically, and then we're going to go back and do the algebraic solution. So our first equation is 6x squared plus 7x minus 4, and we're going to put that in y1. And in y2, we're going to put 2x squared minus x plus 1. And we're going to hit zoom and choose number 6. So there's what our graph looks like. Now we can clearly see that there's a point of intersection right about here. But this second point of intersection seems to be off the screen. So what I'm going to do is I'm going to go into Window, and I'm going to change my Y max. I'm going to double it. I'm going to change the Y max to 20. And we're going to graph that. And now let's see if we do indeed now see our point of intersection up here and a point of intersection down here. So what we're going to do is we're going to the best of our ability, sketch that first curve and sketch that second curve. And we have a point of intersection here and a point of intersection there. So we're going to use the features of our calculator to determine those points of intersection. So we're going to go second function and trace. We're going to choose number 5 for intersect. And I'm going to scroll to the left, use my left arrow, and I'm going to keep scrolling until I'm just about or just above where that point of intersection is, and I'm going to hit enter. When it says second curve, I'm going to hit enter, and when it says guess, I'm going to hit enter. It says that this particular point of intersection, this one right here, is at negative 2.5 and 16. So now we're going to find that point of intersection down there. So we're going to go second function trace, choose number 5, and we're going to scroll down and to the right till we're almost at that point of intersection. Hit enter and keep hitting enter until it tells us 0.5 and 1. So this particular point of intersection is at 0.5 and 1. Okay, so now what we're going to do is we're going to do the same thing, but we're going to do it algebraically. So if you notice in this first equation, it tells us y has this entire value of this quadratic here. So what we're going to do in the second equation is we're going to replace y with 6x squared plus 7x minus 4. And that's going to equal 2x squared minus x plus 1. So all we did is we changed the y to this expression in our first equation. So that expression went on the left-hand side of our equation, and we copied down the right-hand side of our equation. So now what we're going to do is we're going to form one single quadratic equation. So we're going to subtract 2x squared from 6x squared, leaving us with 4x squared. We're going to add x to 7x and get 8x. And we're going to subtract 1 from negative 4 and get negative 5. So there's our quadratic. Now, we want two numbers that multiply to negative 20 and add to 8. Well, that would be 10 and negative 2. And we have to divide those numbers by their leading coefficient of 4. Now, if we simplify this, we divide both these by 2, we get 5 halves. So one of our factors is 2x plus 5. If we simplify this, we divide both by 2, we get negative 1 half, and we get 2x minus 1 as our second factor. So now we need to equate each of those to 0. 2x plus 5 equals 0. So that means 2x equals negative 5. And x equals negative 5 halves. Well, negative 5 halves is negative 2.5. So that matches up with one of the x coordinates that we determined graphically using our calculator. Then we have 2x minus 1 equals 0. We get 2x equals 1. So we get x to be a half, and that's our second x coordinate that we found graphically. But we're not done. Remember, a point of intersection has an x and a y coordinate. So what I'm going to do is I'm going to use my second equation. You could have used your first equation. I just chose to use my second one because it has smaller numbers in it. And I'm going to substitute this x value in for each of the x values in our equation. Now if you type that on your calculator, you take this whole expression that we've got here, 2 times in brackets negative 5 halves squared minus negative 5 halves plus 1 gives us our answer of 16. So y has a value of 16 when x has a value of negative 5 halves. So our point of intersection is negative 5 halves and 16, which corresponds to that left-hand x in our point of intersection that we found graphically. Now we're going to do the same thing with our second x coordinate, which was 1/2. And if you type that in your calculator, you're going to find that y has a value of 1. So our second point of intersection is 1/2 and 1, which also corresponds to what we found graphically. Remember, when you find points of intersection, they are points, so they have to be written as coordinates. You cannot just leave x like this, y like that, then expect the person looking at your solution to realize that, oh, that's a point of intersection. No, you have to actually state that. So there we go. Our graphical solution is supported by our algebraic solution. Now, in your workbook, there's only one example. I think we should do a second example just to make sure you get this. We're only going to do the second example algebraically, though. In this space underneath here, you can write down our second example. And here is our second example. It's 2x squared minus 7x plus 3 and negative x squared plus 6x minus 7. So, as we did before, this tells us that y is equal to this whole expression. So we're going to replace y with this whole expression. We're going to get 2x squared minus 7x plus 3 equals negative x squared plus 6x minus 7. And we're going to combine this to form one single quadratic equation. So we're going to add x squared to 2x squared, giving us 3x squared. We're going to subtract 6x from negative 7x and get negative 13x. And we're going to add 7 to 3, and we're going to get 10. So there's our quadratic equation. Now, if we use box method, we need two numbers that multiply to 30 and add to negative 13. Well, that'll be negative 10 and negative 3. And we have to divide those by the leading coefficient of 3. There's nothing I can simplify in this first fraction. So my first factor is 3x minus 10. I can divide both of these by 3, though,